Today I'm going to take you on a very interesting topic, algebra, which will be useful to you in almost all the topics in maths. We'll be treating addition and subtraction of like and unlike terms. Before I will go to addition and subtraction, I'm going to explain some terms. So we're going to be using alphabet and numbers. Alphabet mixed with numbers. Some of you have not seen this before, but it's very simple. We are going to use alphabet to represent an unknown. Sometimes you do some things like this in puzzle. If I ask you think of a number, add 2 to it, and you get 3. What number do you think of that you can add 2 to get 3? We get this type of question in puzzles. Are you getting it? So I can simply say the number I'm thinking of is 1, because 1 plus 2 is equals to 3. That is algebra kind of question. So instead of think of a number, that number we're going to be using it to we're going to represent it with alphabets. Is that clear? So we are going to, in algebra, from the beginning of algebra to the end of algebra, you're coming across alphabet. It could be any letter of your choice. It could be A, B, C, D, Z. Is that clear? So in algebra, we call them terms, algebraic terms. Is that clear? Algebraic terms can involve just a letter. It can be a letter multiplied by a number. There is a letter and a number together. It can just be a number also. So we call them algebraic terms. Is that clear? Algebraic terms. Then we also have what we call coefficients. Coefficients is the number written before any alphabet. It is very, very important to take note of coefficients because we are going to be using it in all aspects of algebra. All the aspects of algebra, we're talking about the coefficient. Now, if I write 2p, 2 written before p is a coefficient. If I write something like 15w, 15 written before w is a coefficient. Sometimes the alphabet comes alone, like y. Y is alone. The coefficient of y here is 1. Is that clear? So anytime the coefficient is 1, it is not always written. Is that clear? If the coefficient is 1, it's not written. But if it is 2 and above, it is written. In that case, if I have 1 over 2y, the coefficient is 1 over 2. Is that clear? Is that clear? Okay, good. Now, we're going to start with addition and subtraction of algebraic terms. Addition and subtraction of algebraic terms. For example, simplify the following. 10z minus 9z, question 1. Question 2, 3p plus 4p plus p. Question 3 says 11a plus 8a. Now, in solving such questions, solution. In solving such questions, we have what we call like terms and unlike terms. In algebra, any place or anywhere you hear like terms, it means the alphabet are the same. You can add alphabet when they are the same. So anytime they are the same, we call them like terms. For example, in question 1, we have 10z minus 9z. Now, remember I told you earlier to take note of coefficients. Like now, here, the coefficient of z in the first question is 10. The coefficient of z in the second number is 9. What we are going to deal with is going to be the coefficients. Is that clear? So, I have 10z minus 9z. Simple. Just assume you have 10 pencil, you now remove 9 pencil from it. It will give you what? 1 pencil is left. So 10 minus 9 is equal to 1. Remember I said we only deal with the coefficients. 10 minus 9 is 1. Therefore 10z minus 9z is equals to 1z. In algebra, instead of writing 1z, you just simply write z, which is equals to z. Even if you write 1z, it is not wrong. Is that clear? Because 1z is the same thing as z. Is that clear? Now let's go to the example 2. For example 2, we have 3p plus 4p plus p. We are also dealing with the coefficients. 3p, the coefficient is 3, 4p, the coefficient is 4, p, the coefficient is 1. So we have 3p plus 4p plus p. We become 3 plus 4 plus 1. 3 plus 4 is 7 plus 1, 8. So the answer is 8p. 8p. For example 3, we have 11a plus 8a. Remember, we are only adding the coefficients or subtracting the coefficients. 11a plus 8a. It means we are going to add 11 plus 8. So 11a plus 8a is equals to 11 plus 8 is what? 19. So we have the answer as 19a. This is our answer. Is that clear? Now let's go to another example. You have 15b minus 3b plus 2c plus 25. If you check this very well, the previous examples we have solved, they are the same alphabet, means they are like terms. Here we have two different alphabets with ordinary number. So these are unlike terms. We add the alphabet that are the same, then the number remain on its own. So the alphabet that are the same, like I said earlier, are like terms. You can add them together. You can add like terms together. For example, this is 15b minus 3b. They are the same alphabet. So 15 minus 3 is equal to 12. So we have here as 12p. 12p. Plus, there is only one 2c here. There is no other c. There is no other number that has c. So this becomes 2c plus 25. I cannot add the number 25 to 2 and 12 because they are not the same alphabet. Since they are not the same alphabet, they are unlike terms. So this is the answer to this question. Is that clear? Now, this is another question. We have 8p plus 7q minus 4q plus 2p. We have two different terms here. We have p and q. Now, we can first of all collect the letters that are the same together. That is 8p plus, remember, if you are collecting a number, it goes with a sign. The sign here is plus 2p. That is why I'm putting plus 2p. I'm not putting plus 2p because there is plus here. No. I'm picking plus 2p together. So here it becomes plus 2p. Is that clear? Now, this is 7q. This is 4q. This is plus 7q. I pick it together with a plus 7q. 7q. Then you have here minus 4q. I have grouped them according to their terms. The p's together and the q's together. Now, 8 plus 2 is what? 10. So I have here as 10p. Now, 7 minus 4 is what? 3. So I'll have it as plus 3. We cannot add 10p and 3q because they are not the same alphabet. They are unlike terms. So this is our answer. Okay.